This video will focus on isotopes, both defining what they are and introducing the idea of atomic mass. So you should have seen this before, but essentially there's two different ways to report how many protons and neutrons there are. There's the shorthand or there's the superscript notation, and that's just how you count per atom how many protons, neutrons, and therefore electrons there are in that atom. Now, isotope tends to be a strange subject for people. It's potentially not something you've really had to deal with before or really considered what it means. Okay. If we're talking about carbon, the carbon atom, carbon by definition has 6 protons. That's it. That's the only thing that by definition carbon has. Now, sometimes carbon has 6 neutrons in its nucleus also, for a total number of 12 mass, and sometimes it has 7 for a total number of 13. Both of those atoms are carbon. They both have 6 protons, but the difference between them is their mass number. And that's what an isotope is. An isotope is the fact that atoms of an element sometimes contain different mass numbers. And that's because atoms of an element can potentially have different neutrons in their nucleus. The example on the screen is hydrogen. Okay? Most common everyday hydrogen has 1 proton in its nucleus, and that's it. Okay, that by definition is hydrogen because it has 1 proton. Now, if hydrogen has 1 proton and 1 neutron, making a mass number of 2, that's still hydrogen, still has 1 proton, but it's a different isotope. Okay, they're different isotopes of one another. And then if that hydrogen still has 1 proton but has 2 neutrons for a total number of 3 mass, that's another isotope. So essentially, every atom out there has multiple isotopes, okay, multiple masses that it can be. There's one most common one, or one, as we say, most abundant isotope, but you've got lots of isotopes of every atom. So people try to think of, oftentimes ask, what's a regular atom and what's an isotope? And that's not how it works, okay? Essentially, the idea here is that every atom has lots of isotopes. Okay? Carbon has 6 protons, that's by definition, but sometimes it has 6 neutrons, sometimes it has 7. Those are different isotopes. That's it. If you look at any atom, there's lots of different potential isotopes it can have. Some of them are stable, which means they won't be radioactive, and some are radioactive. So a radioactive isotope, or a radioisotope, if you've ever heard of one, is just a particular configuration of an atom, so a certain number of protons, certain number of neutrons that tend to go through spontaneous nuclear decay. And we use radioactive isotopes all the time, in medicine especially, because they give off that radiation that we can potentially detect. So radioactive isotopes exist, but essentially they're one potential isotope of an atom that's not stable. How isotopes affect things is in that atomic mass. So if you look at your periodic table, you don't have a mass number, and that's because the mass number is for one particular isotope of an element. But there's lots of different isotopes. So the atomic mass is, the number reported on the table, is an average. It's an average of all of the isotopes present. So essentially we think of it as if you had 100 atom sample of any given element. If you had 100 atoms of carbon, how many of them would be carbon 12 and how many would be carbon 13? And if you take an average of all of those present, that is the atomic mass that you get on your periodic table. So it's a weighted average. It's not just an average of the 2 isotopes present, but it's an average based on how many are likely to be found. So for example, chlorine has 2 isotopes, chlorine 35 and chlorine 37. And if we took the average of those 2, that would be chlorine 36. But if you look at the atomic mass on your periodic table, you'll see that chlorine is not 36. It's 35.45. What that means is the chlorine 35 is more abundant or more readily found than the chlorine 37, so when it's weighted, it has a more weight to the average. Okay, you've heard of weighted averages before. We weight our grades, right? Your test scores are worth more to your grade than the other ones. So if it's not a 50-50 thing, that's just what a weighted average means. It means not every number is treated equally. So this is just what I said, we'll say it again. The difference between a weighted average and a regular average is that each number doesn't have equal weight. Okay? The weight of the pieces of data for the atomic mass is that we call the percent abundance, or how likely they are to be found in nature. We'll get into the math of this in class, but essentially the difference between calculating an average and calculating a weighting average is that divide. Normally when you do an average, you add up the numbers and divide by how many were part of your average. For a weighted average, you don't do that. Okay? You do not divide in the end. Instead, you multiply each of the numbers by their weight. So if you were going to take an average of these 4 numbers, you just add them up and divide by 4. Okay? Another way of doing that algebraically is, instead of dividing by 4, is to multiply each one by the part that they contribute to the whole. Each one is worth a quarter. So you take the number, multiply it by the percent, add up those total, and that is the average. So with a weighted average, the difference is that instead of dividing by how many digits you put into your calculation, you multiply by their abundance. Okay? You multiply by their weight and add up your final total. We'll do problems like this in class tomorrow. What I want you to be aware of is what an isotope is by definition, right? Atoms of the same element, but they have different masses because they have different number of neutrons. And then the fact that to get that atomic mass, you need to do a weighted average based on abundance. That's it. You should be ready to do the form. It's off of all of the counting of particles as well as isotopes. Go ahead and do the form and have a nice night.